Good day. In today's lecture, we will be having a brief review of the numerical descriptive measure. So I mentioned this is as a review because I believe you have already discussed this before in your basic statistics course back in high school. So we will be looking at the different measures of central tendency, uh, mainly first for the ungrouped data. So we have the mean, the median, and the mode, and what are the relationships among the three. So for the mean. So the mean for your ungrouped data, this is obtained by dividing the sum of all values by the number of the values in the data sets. Basically the average. So for the population data, use the sum of all values x all over the number of population elements in that population or number of values in that population, which is the capital letter N. So when we talk about population, it's in capital letter N. So that's your mean for a population data given by the Greek letter mu. And then for the sample data, it's the x bar. So again, it's the total number of values x over a sample size. So the small letter n refers to the sample size, whereas the big letter N is the population size. So where summation of x is the sum of all values, n is the population size, n is the sample size, and mu is the population mean, and x bar is your sample mean. So another measure of central tendency is of course the median. So the median is the value that divides the data set that has been ranked in increasing order into two equal halves. It's basically the midpoint of all of your data sets when you rank them from say increasing to increasing value or decreasing value. So if the data has odd numbered values, the median is given by the value of the middle term in the ranked data set, whereas if you have an even number of values, the median is the average of the two middle values. So let's look at some examples. So in calculating for the median, you need to first rank the data set in an increasing order and then divide them, know where the exact half is. So basically, you would know where the dividing line is by knowing the total number of samples or the total number of population n, and then divide it by 2. So for example, if you have 6 data sets, so the dividing line, 6 divided by 2 is 3. So count 3 data, so you are around now the median. So let's look at this example. So we have a list of the salarymen. What's this again? 2019 salaries of 11 college football head coaches. So what's the median of all of these data? So the data here is not ranked. So you need to first rank the data. So given the ranked data, so you have a total of 11 values. So it's an odd number. So n is an odd number. So when you look at the median, so you just get the one that is at the exact middle. So from the list, the one 11 divided by 2 is actually 5.5. So if it's I think let's for an odd numbered value. So 11 minus 1 divided by 2. So 11 minus 1 is 10. 10 divided 2 is 5. So that means you need to get 5 data, and then the next data after the fifth one is your median. So that means you have here for 11 values 5 before and 5 after your median. So it's 4.5. So basically it's the number that gives exactly, or the position or the data point that is positioned at exactly the midpoint of your data, where your data is say for example uh, rather if you have ranked it, so it's the exact position where 50% are greater than that amount and 50% is less than that amount. So that's your median. So the median here is 4.5. Now, how about for an even number of data? So what's the median for the even number of data? So again, you rank them. So these are 12 you have 12 data values. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 data values. So the exact midpoint of this one is actually between values 6 and 7. So what the median will be the midpoint of the 6th and 7th value. So basically, the median is in the middle of this one. So the middle of that one. So Add the two values, divide them by 2, and that is your median. So that's that's the value for the median. So just a brief note on the median. So the median gives us the center of your histogram. So when when you plot your data, you will get the exact midpoint. For a histogram, it's the exact center. Half of the values to the left of the median and half to the right of the median. So one advantage of using a median is that it's not influenced by outliers. So for example, in this data, even though this is 3,864, very, very high, and this one is actually very low. So it's actually 1,000. This 3,864 is 1,000 or more higher than the previous one. So it can be considered a very, very far-flung value. The median or the central tendency or the central point here stays at this point. So you will have basically no outliers can influence it because you don't really consider any outliers. You're just concerned with how many data you have and what when you rank them, what the two data that's around the middle portion, if it's an even number data or the exact middle data. So for data that has outliers, where the outliers, you cannot eject the outliers. So they tend to use the median instead of the mean because the mean, especially for ungrouped data, the mean is actually, it can be influenced by the amount of the outliers. So your mean can be very, very small or very, very large depending on the position of the outlier. So if your outlier is on the larger side, your mean would tend to become or rather would tend to be on the larger side as well. Whereas your median will stay always at the center. So the third measure of central tendency is the mode. So the mode is the value that occurs the highest frequency in your data set. So example here are your data for speeding violation. So what is the mode? So what number occurs the most number of times here? So you can see here 74 occurs twice. So it can be considered your mode. So whether it's the highest or the lowest, as long as it's the most number, it's the data with the most number or most amount in your set or data set, that is your mode. So one shortcoming for the mode that it is also the reason why it's you don't always see mode. You usually see, especially for data sets, you usually see, of course, the mean, even the median. But very rarely will you see mode to be used as a measure of central tendency because it's a very arbitrary value. Rather, it doesn't really give us much of an idea where the center of your data is. Rather, it just gives you which occurs most frequently in your data set. So sometimes your data set can also have no mode. That means all of them occurs at exactly the same amount of time. Not only once, but for example, all of them occurs exactly twice. So there is no, they are all at equal position. So there's no mode in that data, or it may have more than one mode. In a case that there are two values that occurs twice or thrice more than the other data. So unimodal, bimodal, or multimodal. So example here, 5 randomly selected families and their monthly, incomes. So since there is no repeating data, you will have, there is no technically mode. You don't really see a mode for continuous random variables or continuous variables. Usually see them in either categorical variables or in qualitative variables. So here is another example for the 12 employees that are the amount of times, or rather the amount of time it requires them to commute from home to work. So here you can see that two values occurs twice, 14 and 23. So 14 and another 14 here, we have 23 and another 23. So there are two data that occurs exactly twice. So you have two modes, or this is actually a bimodal data. So enough of the disadvantages of the mode, but how about the advantages? For the advantages of the mode, so as I talked about before, if you have categorical data or if you have data that is qualitative, having the mode is actually the most common measure of tendencies. because of course it gives us say majority of the people chooses this amount of data. So basically that's your mode. So it can be uh, it can give you a qualitative analysis for qualitative and not only for quantitative data but also for qualitative data. So examples, you have 5 students with status whether they are senior, sophomore, or senior, sophomore, or junior. So the mode here is the senior because it occurs the most. So 3 times. Senior, senior, and another senior here. So you basically have here categorical or non-numerical data, but you can still find a mode because, of course, the mode is not limited because it's only concerned how frequent, the most frequent data that appears. So that's your mode. So other measures of there are some workarounds because as you noticed from before, especially when we talk about the median, we had looked at data why median was preferred when you have outliers is because medians are not influenced by outliers, whereas mean, since you are dividing it by the total amount, so you are getting the values of all the data and then dividing it by the total amount, it is they are actually influenced by outliers. So one way to prevent that is trimming the data. So you are basically removing possible or potential outliers. So whenever you do this one, although this is not a common this is not a common practice because when you trim the data, you always lose information, and that is what you don't want to have. You want to have the exact rather not the exact the optimum amount of information that you have for your selected data. What if the trimmed data is actually quite important and will have a significant impact in your study? So we rarely do the actual trimming. Rather, we just get the or rather assess whether the outlier is really significantly whether that outlier is a significant outlier or not, whether we should do that or not. So you have a separate test for determining the outlier on a certain number of trials or certain data sets. So anyway, for the trimmed mean, you are just going to simply drop the 5% or usually it's 5 or 10% of a certain data. So for example, you have 10 students, you calculate the 10% trimmed mean. So you cut off 10% of that data. So 10% of the 10 values is 1. So you drop 1 value at each end. So you trim 10% of both sides. So you basically lose 2 data points. Regardless whether those data points are outliers or not, you lose them. So that is your trim mean. So your trim mean is the mean calculated when you cut off not exactly outliers, it's the extreme ends of the data. So that the last and the first data in your data set. So the highest in the and the lowest, I mean. So that's your trimmed mean. So another one is calculating the weighted mean. So for a weighted mean, you assign a frequency or a value to a certain data sets. So that means there's a weight there is a weight on a certain data on your data set. It's actually usually used usually see them when calculating your grades at the end of its module or each term. So you have here, for example, calculating the weighted average or weighted average grade. You have the module exam, for instance, has higher weight than your say activities. So even though you have a high value for the activities, if you have a low module exam, the weights assigned to each category, which is, for example, the exam and the activities, it actually has a significant, or rather, it will greatly affect the weighted mean. So the weighted mean is actually calculated by getting the data set times the weight, the provided weight over the total sum of your weights. So here is a non-grade example. So you have 10 gallons at a price of 260 per gallon, 13 gallons at 280 per gallon, 8 gallons at a price of 270 a gallon. So what is the average price for the gasoline? So he had he bought he or she I think it's a she. She bought gas 4 times. So there's a varying price at each time, and they have a different weights or amount she bought for each particular time she bought the gasoline. So what's the average amount that he paid? So basically, the calculating the weighted mean is just multiplying the data set, which is 260, which is your data, the amount, particular data in your data set, and then its weight, which is, for example, here is 10 gallons. So X times W, and then same for all of the data. You sum everything, and then also get the total weights. So for getting your weighted mean, you just divide the two summation. So this is 2.72 a gallon. So that's the average amount Maura paid for a gallon of a gas in 2015. Okay, so looking at the relationships between the mean, the median, and the mode, we can look at it at, say, we can form a symmetric histogram and frequency distribution with, or rather, we can look at a symmetric histogram for that. So, for a symmetric variable, or rather, in an ideal world, you will have a bell-shaped curve where the mean is equal to the median and the mode for your population. Especially, actually, this is, I won't have to actually limit myself in a very ideal situation, but the law by the law of large numbers, and we have discussed this in probability distributions in the previous lectures. For very very large amount of samples, you will get the mean is equal to the median is the mode, and your the distribution, the probability distribution will resemble a symmetrical bell-shaped curve. So for a symmetrical bell-shaped curve, you have the mean, the median, and the mode is exactly the same data point or data set. Whereas in a non-ideal world, sometimes there are some data that are skewed. So it's either skewed to the right or skewed to the left. So if it's skewed to the right, you have a very large mean, you have a small mode, and of course the median is always lying between the two. And that is why some people really prefer median, because it's really at the middle of everything. So it's in the middle of it's always at the middle of the mean and the mode. But just knowing the median value won't tell us what would be it has a limited amount that it can tell us, such as, of course, the relative frequency. Because if you look at this one, so you have a mean, median, and a mode. So for data that is skewed to the left, the majority is on the low end. So the majority of your data is on the low end. So you have the mode here. But since you have a very high values, or very high values on there are small amount of very high values, it actually pulls the mean, because the mean is you sum all every values and then you divide it by the total amount. So if you have a very a small amount of a very high value of your data, your mean will be somehow pulled a little bit to the right, whereas your mode, since your data tends to have a higher frequency at the low side, you have a mode at the left side, or at the low side of your data. And of course, the median is basically still at generally the center, although it's not exactly the exact half of this one, but it's between the mean and the median. And that is why sometimes for this type of data, they tend to prefer the median, or even sometimes even the mode, over the mean. So another example here, this one is the opposite. So it's skewed to the right. So if it's skewed to the right, you tend to have a high frequency in the higher side of the spectrum, whereas you have a very actually low a tail at the lower end. So this time the mean is on the mean was pulled toward the low end, because you have a very low a small amount of a very low variable that pulls your mean to the low end side. And then of course the median is always between the mode and the mean. So regardless whether it's skewed to the left or skewed to the right, your median is always between the mean and the mode. So your mean and mode can be affected by the frequency, which amount, and of course especially for the mode, the frequency where a certain amount tends to have, and for the mean, it tends to be affected very much by outliers, or very high values that are very small in number. When I say small in number, small in frequency, I mean. So that's it for the mean, median, and mode. And so in the next time, we will talk about measures of dispersion.